I wanted to discuss a bit about the idea of sensitive information disclosures, or in general, just information disclosures. And these are situations where, in an application or server or some sort of thing that exists on the internet, we're able to disclose information from that service that tell us either sensitive details about a user, for instance, or sensitive data about a session, or sensitive data about the web application itself, or give us more information that we can expand our attack surface. So this is a really big step in not only information gathering, but actually exploiting systems in general. So I'm going to show you a few different examples, and I'm going to talk about a few different examples as well to give you a bit of a feel of what exactly happens with information disclosures and why they're a bad thing. Now, there's a huge variety of different types of information disclosures, and I'll try to talk through a couple of examples of each of the ones that I'm most familiar with, and that should hopefully give you a good idea of ones that are common sort of in the current environment or systems that exist. So to start off with, one of the most common types of information disclosure is error messages that are displayed to the user. In general, when we have error messages, we should try to make sure that they are error messages that are controlled by us. So the way that we do this is using try-catch statements with custom messages that output information that is descriptive enough for the user to understand what happened, but not so descriptive as to reveal information to the user. To give you an example of this, I have a login page here. And when I input like a username and password, it would say your username or login is invalid. This would be a great example of a proper error message because it doesn't expose any real information. Now, if it exposed something by saying like the login doesn't exist, this would be an example of a very simple information disclosure. What that tells the attacker is it tells the attacker that the login that they're trying to attack isn't one that exists on the system, so then they can try a different login. They know it's not the password, it's just the login or username. Now, when we keep it more vague, it tells them one of the things that they entered was wrong, which means that they can't sort of understand if the user exists or not. So this is an example of something that could potentially have an information disclosure. We have to be very careful about error messages. Even further, if we leak an error message, for instance, this one has a SQL injection available in it. So if I put a single quote, for instance, you'll see we get this PHP warning outputted to the screen. When this happens, it's a problem for a lot of different reasons. First off, it exposes information about the SQL function that I'm using for the login. It exposes the location of the actual file, like the full server path. It exposes a little bit of information about like the location of this error itself. And as well, it exposes the fact that we have an error in the SQL query, which in turn tells us that a SQL injection is likely possible here. So this sort of information disclosure tells us information about the system in terms of how it's handling the SQL queries. In this instance here, it's telling us how we can attack the server in a little bit more detail, because now we know the single quote caused an error in the SQL handling, which in turn tells me that it's interpreting it as code, which in turn tells me that I can create a SQL injection type of scenario with it. So this is another good example of sort of an error message type of information disclosure. Now, there are other types of information disclosures that are very common. One actually comes with Apache, and it's one of the sort of defaults of Apache or XAMPP or those sort of server setups. What you'll notice is that if I put in something that doesn't exist, I get this typical 404 error page. Now, this looks quite innocent because it just sort of says object not found. But if you're paying attention, you'll notice that it exposes this server, the version of the server, the operating system type, the version of my OpenSSL, as well as the version of my PHP. And you may be thinking, well, that doesn't really seem like that big of a deal. However, we can easily now take this information and look up CVEs for that version. And from a site like CVE Details, you'll be able to see, okay, in 2019, there were all of these vulnerabilities that work for this specific version of Apache. So from here, I can just pick one that I want. So for instance, this here, I could try using to attack the system because I know the version of the system itself. So once I know the version, I can easily find attacks that could potentially work against that version number. So exposing the version number is extremely dangerous because it allows the attacker to know what they should be attacking. It tells them the version number, which is easy to sort of find these different CVEs for. So this is another example of an information disclosure. To solve this sort of problem, we can have like custom 404 error messages. And you can do that through like the configuration of the Apache server itself. And that's typically the preferred way to handle that rather than using these default ones. Now, one other common one that comes up is access to log files or configuration files that have sensitive information. You'll actually see this a lot. There's a lot of methods such as like Google Dorking, for instance, where you can look up configuration files or log files. And oftentimes you can find ones that don't have the proper permissions on them that may expose a username or password or cookie or some piece of information that is important to keep anonymous or secure. An example that I have here is, so if I go to my localhost directory, I'm able to traverse my directory here, and you'll see that I have this conf folder, and then I created this config.txt, and you can see it has all the information about my username and password and database. So these types of configuration files can exist on your system. However, they shouldn't be accessible by an outside user. Otherwise, they're able to potentially find these and be able to disclose information about the actual system itself. So we want to make sure that any configuration files or logs are not readable by the users if they don't have to be. If they are readable by the users, they should not contain any sensitive information. This sort of information you see a lot. One of the most common places where you see this is if you, say, run an installer for an application itself. Sometimes that installer will have like an install log, and inside of that install log, sometimes they might be like database initialized with these parameters, and they might accidentally put the password in it, for instance. And that just means if someone breaks onto the computer, they can easily find that installation log and they can get all that detail from you. So we want to make sure that that sort of information isn't being exposed in our logs or configuration files. So then the other type of information disclosure that's very common and very dangerous is about like plain text transmissions and plain text storages of sensitive information. So as an example with this login page, you'll notice that we don't use HTTPS for it, of course. So if we use HTTPS, what happens is we create a secure socket between the server and the client. So it means that all the data transmitted between them will have encryption enabled on them, meaning that if someone sits in the middle of the two connections, they won't see any plain text information. They'll see encrypted packets, and we'll have to figure out how to decrypt those packets to get any valuable information. However, if we submit without HTTPS, which for this example we would be doing, when we send the packet from the client to the server, it would send in plain text, which means that the username and password would be exposed. In addition to this, when we send the password, in this case, I'm not sending the password with any sort of encryption or hashing applied to it. I would apply the hashing maybe server side. And in that case, when it's transmitted in plain text, which is another dangerous thing to be doing. We don't want to ever transmit our passwords in plain text if we can help it. And speaking on the half of hashing passwords, passwords in databases should always be hashed, specifically with a salt as well. And the reason for this is because if the database ever gets compromised, they will only have the salted hashes of the passwords rather than having the passwords themselves, which means that they have to crack the passwords. And this makes it more complicated for the attacker to actually get that information because they'll have to do like brute force attacks or dictionary attacks. Hopefully dictionary attacks wouldn't work because you would have a random salt, but brute force attacks essentially would potentially work if the users pick weak passwords. So with a good password policy and hashing on the password, it becomes rather hard for an attacker to be able to expose that data. Now, there are things other than passwords that are important. Unique identifiers like, I don't know, driver's license numbers or SIN numbers, bank details, that sort of information can often be compromised. So we want to make sure that that information is sort of redacted or hidden in our database. So typically we'll obscure it in some sort of way, or we'll hash it or do something with it in order to allow us to not be able to store that just in plain text. So we want to be able to adequately protect that data as well. Now, speaking of sensitive data storage, another piece is when we have sensitive data inside of source code. Now, a lot of people think that, for instance, if you write like a Java application and you compile it, we think, well, nobody's going to be able to see the source code now because we've compiled it. There exists a lot of decompilers and reverse engineering programs that allow you to decompile code and turn it back into source code to read it. If we have passwords and usernames in plain text in that code, then somebody can just decode your binary just through like decompiling, and then they can just browse through it and search for the password. You'll actually see this very often with sort of like amateur keyloggers or that sort of thing. When people put up like those scam things for like games like, for instance, Fortnite, where they'll put up like a thing that will like generate the currency of the game, and you just type in your username and password and you click OK, and then it, gives you free money or something like that. With those sort of programs, you can often decompile them, and those people will put the email that it sends those credentials to in plain text, so you can actually see that information. So that's something that's very common, and you see it a lot, especially with people who aren't particularly skilled with programming. They often put their passwords in plain text in their source code because they think no one can get back to the source code once it's compiled, but they can. So keep that in mind. In addition, like even with PHP files, when we talked about like the Ghost Cat vulnerability, for instance, the Ghost Cat vulnerability allowed you to pull pages from an Apache server that were anything, right? So you could pull the PHP code and then in turn expose like configuration data and potentially expose username and passwords as well. So that's another thing that you want to look out for. Ideally, what you should be doing is having the person put in a password whenever they have to authenticate to a service, or it should be stored in maybe a third-party sort of way, or using some form of encryption, perhaps. There's a lot of different methods that you could do. I think typically what a lot of people do is they will encrypt the password, and then they'll store the key for that inside of the key store of the computer. And then whenever they need to access it, they use the key from the key store to decrypt the password, and then use that password to authenticate to the database or whatever they're authenticating to. I think that would typically be it. You also see things like API keys becoming more and more common, because if those get leaked, you can just revoke the API key and it's not as big of a deal. But there's a lot of different alternatives next to just using a password in plain text, so you just want to consider those as well. Now, there are a few other small ones that I'll discuss here briefly, just to give you a few more ideas of sensitive data disclosures. Things like timing-based attacks are actually common. Sometimes when you log in with a username and password, when you log in with an invalid username, it manages to check it faster than if you log in with a valid username. If you ever see something like that happening, you can actually time it and determine if a user exists based on how long it takes to authenticate. The reason being is because they might do like a query to begin with to check if the username exists, and then check the password only if the username exists. So you skip that second step, which means that the process completes faster, which means that you could do timing-based attacks. Another one that's become fairly relevant, especially right now, is revealing chain of command through email auto replies. So this one's a very different one from the ones that we've discussed so far. When people are out of office, they'll typically put an auto reply on their email. It'll say something like, I'm out of office right now. Please contact this person if you need something urgently. And what that essentially exposes to the attacker is now they see that somebody is covering for you, or someone is your superior. So then they can go to that person and be like, hi, I was talking with, this person and they were going to give me this information. I'm wondering if you can help me with that. Since the other person's out of office, the other person's covering for them, it's a bit easier potentially to get that information out of the person who's covering, because they won't necessarily know that context. So you have to be very careful about the information that you're showing people. The final thing that I'll talk about here as well is the more classic versions of information disclosure, and those are being able to get access to data that you shouldn't be able to get access to. The most classic version of this is like SQL injections. If you can do a SQL injection, you can typically query other tables to get information, and when you can query other tables, you can disclose information that you shouldn't have been able to see before. So that's sort of like the classic information disclosure that allows you to grab information from another table. So to sort of summarize this, when we have any sort of information that is being provided by our application, we need to be very careful about it. If you ever have an instance where your application could potentially error, you should make sure, for one, that the default behavior is not used, that you are controlling every error message, and for two, that you're catching every error that could potentially happen and printing a message that is not the stack trace. Something that is written by you that does not expose any information about the application itself. Same goes for things like the Apache 404 page, for instance. Any of those responses, you should try to make them customized to your application so that they don't accidentally expose something that's of value. So that's something very important to note about those. In general, good programming practice of not having SQL injections, command injections, XXE, XSS, getting rid of those vulnerabilities so that we can't disclose information, making sure that you aren't revealing information through email auto replies or external facing processes. And that's the general idea of sensitive information disclosures. So it's always good to be careful of the information that you're displaying to people. if ever you need to print something to the screen or show the user something, you need to make sure that you are being careful of what you display. That's essentially the main theme here. So using these sort of ideas, you'll be able to better secure your application to hide information from the users and thus prevent attackers from being able to expand their attack surface or potentially compromise your applications.